we'll get started. Okay, so integration of parametric equations. So just write this down. I always like to have nice notes for you. So to find the area, between a curve and the y-axis, where y equals f of x, we calculate the integral of f of x, or alternatively the integral of y, because y equals f of x, dx, between two x limits, x2 and x1. Typically, x1 will be the lower limit, x2 will be the rightmost, the upper limit. So we calculate the integral of y dx, and that doesn't change with parametric equations. So let's just do a little quick diagram. Hopefully I'm not patronising you too much by drawing just what I mean by the area between the curve and the x-axis. So that's y equals f of x like that. Sorry, Josh, just seen your message. Yes, I'm good, thank you. So y equals f of x, and that doesn't change even if the curve's parametric. So even if we are given parametric equations, this principle does not change. So what we're going to do, we're going to go through step by step, some quite lengthy exam questions on this, and that's what the duration of the lesson is going to be all about. Just being able to tackle this topic. So got that there. And I'm happy for these lessons to be interactive. You've got the chat facility there. If there's anything that you're unsure of, do feel free to interrupt me at any point, and I'll happily answer any questions. Otherwise, it just turns into a bit of a lecture, so feel free to ask. So the curve shown in figure 2 has parametric equations x equals t minus 2 sine t and y equals 1 minus 2 cos t, where t is between 0 and 2 pi. Show that the curve crosses the x-axis, where t equals pi over 3 and t equals 5 pi over 3. So the curve crosses the x-axis when y equals 0, there and there. Again, hope I'm not patronising you by telling you that, but it becomes much easier when you just think y equals 0. So take a moment, find the values of t for which y equals 0, and I'll give you a clue. There they are there. You've just got to get on paper the process of actually doing that. So my answer to part A I'll do here. So y equals 0, which implies 1 minus 2 cos t equals 0, which in turn implies 2 cos t equals 1, which means that cos t equals 1/2. Which means that, so calculator, make sure I'm, does this need to be written? Yes. So, daft question that I asked myself there, does it need to be in radians? Basically, any sort of calculus needs to be in radians. So, inverse cos of 1/2. What I've said isn't strictly true, by the way. Calculus doesn't need to be in radians, but for the purposes of A level, that statement's true. Third pi, which means that t equals 1/3 pi, and just a quick sketch of the cos graph, like that. We can see that one solution's a third pi from the left, so the other solution's a third pi from the right, which gives me 5/3 pi as required. So that bit's done. Right, so next part. I'm just going to drip feed you the parts of this question here because they can be quite overwhelming if thrown at you all in one go, and they take up most of the screen as well. So there it is there. There's the second part. The finite region R is enclosed by the curve and the x-axis as shown shaded in figure 2. Show that the area of R is given by that integral there. And this goes back to what I was saying before. The answer is always, the way to do this is always the integral of y dx. The integral of y dx between the two x limits. In this case, the two x limits are these numbers here, but we've actually converted these into t limits already. We've converted these into t limits, which is what we're going to need in a bit. So the integral of y dx, well, that's equal to, we know that y is equal to 1 minus 2 cos t, 1 minus 2 cos t dx. But we can't integrate t's with respect to x. So basically, what we're going to do now is a little technique from integration by substitution. We're going to try and relate dx to dt by finding the differential. Dx by dt equals, and we can see that if we differentiate that there, dx by dt, we get 1 minus 2 cos t. Which means that dx equals 1 minus 2 cos t dt. So this now, dx, we can replace it. That there can replace that one there. Equals the integral of 1 minus 2 cos t dx, and dx is equal to 1 minus 2 cos t dt. There we go. So we're replacing the dx with that. Got a bit ahead of myself there. 1 minus 2 cos t dt equals the integral of exactly what we're asked to find, 1 minus 2 cos t squared dt. And basically we've found the limits earlier, so we can just put those in, 5 pi over 3 and pi over 3. Right. We've done that part. We've actually shown that that's the integral. It never asked us to find the area though. However, the next part of the question is going to do just that. It's going to ask us to use this integral to find the exact area. So I'll leave that there. And this one, I want you to have a go at. I want to give you a few minutes to do that, because this basically employs all the techniques that we've learned over the last few weeks. So take a moment to have a go at that. Well, go on, let's try and make this a bit more interactive. Put in the chat what you think the first step here is. So we've got the integral we need to do. Type in the chat what you think is the first thing that you should do. Expand the bracket, yeah. Matiana, yeah, certainly do. So that becomes the integral between 5/3 pi and pi over 3. So expanding the bracket, we get 1 minus 4 cos t plus 4 cos squared t dt. And technique-wise, there's a lot to process there. I would try and split this up into 2 separate questions. The easy part, part A, and the hard part, part B. So I would do part A first. So get the easier marks first. So do that integral, 1 minus 4 cos t, between 5/3 pi and pi over 3. So A becomes t minus, and the integral of cos t is sine t, so t minus 4 sine t between 5/3 pi and 1/3 pi equals, then just sub the limits in. So we've got 5 pi over 3 minus 4 sine of 5 pi over 3, take pi over 3 minus 4 sine of pi over 3, like that. And 5 pi over 3 take pi over 3 is 4/3 pi. So minus, minus 4 sine of 5/3 pi. We're putting the calculator there like that. Maybe avoid confusion, would be positive 2√3, so plus 2√3. And double minus 4 sine of pi over 3 again, just to avoid any confusion, over 3 equals 2√3. So equals 4/3 pi plus 4√3. There. And now part B, the hard part. Any ideas how we integrate cos squared of t? Any ideas? And this is really just a test of memory. Yep, compound angle formula. What we're going to do is we're going to expand cos of 2t completely in terms of cos t equals 2 cos squared t minus 1. We're going to use this well-known trig identity to replace cos squared t with something equivalent that we can integrate, which means that cos of 2t plus 1 equals 2 cos squared t. And we're being asked to integrate 4 cos squared t, so times both sides by 2, which means that 2 cos of 2t plus 2 equals 4 cos squared t. So we've taken 4 cos squared t, and we're about to change it into something we can integrate, i.e. that there. So equals the integral of 2 cos of 2t plus 2 dt. That's the equivalent of integrating 4 cos squared t, which is equal to, so integrate that, cos integrates to sine, so we get 2 sine of 2t, but remember we need to divide by the differential of the bracket, divide by 2, plus 2t between 5/3 pi and pi over 3, like that. Let's sub the numbers in. Equals sine of 2 lots of that, so sine of 10 pi over 3 plus 2 lots of 5 pi over 3 minus sine of 2 pi over 3 plus 2 lots of pi over 3, like that. Sine of 10 pi over 3 equals minus root 3 over 2 plus 10/3 pi minus sine of 2/3 pi so minus root 3 over 2 minus 2/3 pi, like that, which is equal to minus root 3 minus, plus 8 pi over 3 is that part. So we've got that bit as well. Finally, putting it all together, add the two together, a and b. So a plus b equals 4 pi over 3 plus 4 root 3 minus root 3 plus 8 pi over 3. So that gives 12 pi over 3, which is 4 pi plus 3 root 3. Like that. So they seem quite difficult, and they are initially, but if we break it down into steps, it just feels a lot better. So I think the trick here was to divide the question up into 2 separate parts, A and B, like that. So let's do another. Exactly the same principle, the integral of y dx. Now what you are allowed to do, there is a formula if you want to, rather than remember the process, if you just want to remember the formula, it's that there, integral of y dx by dt, dt, and you are allowed, as I say, just to remember that. And the logic behind this formula, it's exactly what we did before, the dt's cancel to give y dx, so it's the equivalent of integral of y dx, but if you use that formula, you'll get it right every time as well. So the curve C has those parametric equations there. The finite region R between the curve C and the x-axis, bounded by the lines with equations x equals log 2 and x equals log 4. Basically, a lot of words, but it's just describing this area here, is shown shaded in figure 3. Show the area of R is given by that integral there. So follow the same process that we did before, the integral of y dx, but what we need is t limits here. These must be t limits. Currently we've got x limits. Make sure, the bit that people forget, make sure you put t limits there. So take a couple of minutes yourself, have a go at that. I'll take over in just a moment. So as before, it was the integral of y dx, or as I say, you can use that formula there. And don't forget the limits, just to find the limits. So x equals log 2 implies t equals 0. So if x is log 2, to get log 2, t has to be 0. X equals log 4 gives t equals 2. Again, t equals 2 means x is log 4. Therefore, I equals, I for integral, just a typical letter used to say that which we were asked to integrate, is equal to 1 over t plus 1, t plus 2, dt between our two limits, which are 2 and 0 as required. So hence find an exact value for the area. So you've got to search the depth of your mind, look through every integration technique you've learnt, and come up with an appropriate one that's going to help us here. So go through every integration technique you've learnt and settle on one that will solve this particular problem. Any ideas? Correct, yes. Split the fraction. So the technical name for that is partial fractions. Yep, so we can split this up into partial fractions, which will then allow us to integrate. So 1 over t plus 1 t plus 2 is identical to a over t plus 1 plus b over t plus 2, like that. Multiplying by the denominator, we get 1 is identical to a t plus 2 plus b t plus 1. I'll give you a moment to sort that out yourself. So I'll quietly get on with it while you can be checking your answers against mine. So we've got that integral now that we're split it up into partial fractions. Keep going. So it asks for an exact answer, an exact value, and we've given that. There's no benefit to going any further than that, but it might be nice. It's nice just to practice writing the logarithms and combining them. So what I'm going to do here is log of, so 3 plus log 2 is 6, using log laws. So subtract the log 4, divide by 4, equals log of 3 over 2 is our final answer. A few more parts to this. Well, 2 more parts. Find a Cartesian equation. So I'm going to remind you of the equations. There they are there. So find the Cartesian equation of that, i.e. eliminate t. And it specifically wants it in the form y equals So there's a lot of work you can cut out for yourself by starting with one particular equation, given that you need y equals as the answer. So how I would do this, x equals log of t plus 2. If I e both sides, e to the x equals t plus 2, which implies that t equals e to the x minus 2, like that. So that means that y equals 1 over t plus 1 t plus 1 equals 1 over e to the x minus 1. And there's our equation y equals, just to conclude, y equals 1 over e to the x minus 1. One more mark, part D. State the values, state the domain of values for this curve. So you'd be forgiven for thinking here that t could be anything bigger than minus 2, because log 0 and below would break it. But actually there's a further restriction here. It's made the domain smaller than it needed to. T is bigger than minus 1. So the smallest value of t is minus 1. If I sub that in there, let t equal minus 1, which means that x equals, because the domain is x values, log of 1 equals 0, and we know log function increases, therefore the domain of x values is x greater than 0. So t bigger than minus 1 gives x values bigger than 0, and that's that done. Let's have a look at another one. They do take some time, these questions. Right, another. So that one there. Made that a bit too big. That'll do. There we go. So figure 3 shows the curve C with parametric equations x equals 8 cos t and y equals 4 sine of 2t, where t takes values between 0 and 2 pi over 2. The point P lies on C and has coordinates 4, 2 root 3. Find the value of t at the point P. The value of t at the point P. 2 marks, so there must be more to it than just doing an inverse cos. So x equals 4, which implies 8 cos t also equals 4, which means that cos t equals 1/2, which means that t equals inverse cos of a half, which is pi over 3. Now we've got to check that with the y coordinate to see if it truly does generate that particular point. So for sine of 2 lots of pi over 3, is 2 root 3 as required. So I'm going to check for sine 2 pi over 3 equals 2 root 3, which is right. Now the reason I did that check, just to explain, t equaling pi over 3, well actually t equals 5 pi over 3 would also give x equals 4. Let's see, 8 cos of 5 pi over 3 gives x value 4 as well. So let's sub it into the sine and see if that actually does give us the sine that we want, so the y value that we want. So 4 sine of 2 lots of that doesn't give us it. It gives us minus 2 root 3. So that's the reason we checked, because just because we get the x coordinate doesn't necessarily mean we're going to get the y coordinate right. And this example here, where x is 5/3 pi, gives us the x coordinate but not the y. That's the reason we did that. Right, part B. The line L is a normal to C at P. Show that the equation for L is that there. So that's all we need. Don't need to see the diagram yet. The line L is a normal to the curve at P. So we've got the point P. We've got the t value at P. Therefore, we can find the equation of the normal. Equations for x and y, find dy by dx parametrically. Then use the standard method. I'll give you a few moments, then I'll guide you through it again. Put that a bit higher. I know it will go over the page, but not so bothered. Okay, so dx by dt equals minus 8 sine t. dy by dt equals 8 cos of 2t. Remember to times by the differential of what's in the bracket for that one. Which means that dy by dx equals 8 cos of 2t times the reciprocal of dx by dt equals, so 8 over minus 8 disappears, so we get minus cos of 2t over sine t, which when t equals pi over 3 gives dy by dx equal to minus cos of 2 pi over 3 divided by sine of pi over 3 which is equal to root 3 over 3. We can see there's a root 3 in the answer, so we're looking to be along the right lines. We know the point P now, we know both coordinates, so we're ready to sub this into the magic equation. Y minus y1 equals m, x minus x1. Therefore, y minus y1 just realise it says normal, doesn't it? Not tangent, it says normal. So actually, that's the gradient of the tangent, therefore the gradient of the normal is minus 3 over root 3, like that. Negative reciprocal. Therefore, y minus y1 equals mx minus x1. Y minus y1 equals m x minus x1 times both sides by root 3, which gives root 3y minus 6 equals minus 3x plus 12. So is that anywhere near what we were asked to find? Well, let's rearrange it to say y equals. So divide everything by root 3. Y minus, so 6 over root 3 is 2 root 3. Minus 3 divided by root 3 is minus root 3 x plus, and 12 over root 3 is 4 root 3, like that. So make it say y equals, which means that y equals minus, and we'll write that as x root 3 as required, minus x root 3. Indeed, 4 root 3 plus 2 root 3 is 6 root 3. So we've got the answer. Now for the integration part. Pop that there. Try again. So there it is there. And I'll just put the information in the question up again. Just put it to the side there so you can. For now, I'll delete it in just a moment. So there's the equations there. So it wants you to find that area, or rather it wants you to show the areas given by that integral. So you know what to do. Same as the last two times. The standard formula for integrating parametric functions. And show that it equals that. So the integral of y dx, as always, equals, and we know that y is 4 sine 2t, so the integral of 4 sine of 2t dx, I'll just write over this for now, and dx by dt, just move that across there. So a bit of a sideshow here. Dx by dt equals minus 8 sine t. And I should have just copied that from what I wrote earlier, because we've already done that. We've already done dx by dt, which means that dx equals minus 8 sine t dt. So we can say that that's equal to the integral of 4 sine 2t dx, which is minus 8 sine t dt. Move that a bit further down. And then multiplying out using compound angle formulae equals the integral, so of 4 lots of 2 sine t cos t times minus 8 sine t dt equals the integral of minus 64 sine squared t cos t dt. So there's a bit of a twist. There's this minus sign appeared, and it looks like it's appeared from nowhere. Let's first of all put the limits on there. So going back up to the function, actually we can do from this diagram here, can't we? The two x limits are 4 and 0. So the lower limit is 0. X equals 0 implies that, and remember this is the lower limit, x equals 0 implies that 8 cos t equals 0. Which means that cos t equals 0, which means that t equals, save a bit of space, cos t equals 0, which means that t equals, so the arc cos of 0 is pi over 2. The lower limit is pi over 2. Upper limit, x equals 4, implies 8 cos t equals 4, which means that cos t equals 1/2, which means that t equals arc cos of a half, which is pi over 3. The upper limit is pi over 3. Now let's go back to what the question asked. Look at what it's done with the limits. The upper limit and the lower limits are in the wrong place. If we swap them, it means we'll do the subtraction in the opposite order. So we can get rid of that negative sign by simply swapping the upper and lower limits now. Swap the upper and lower limits, do the subtraction in the opposite order, and it's going to give us negative what the answer would have been. So that's a neat little trick that probably rarely comes up on exams. Might come up, might not, but it's something to have in your repertoire. Pi over 2, pi over 3 on the bottom, 64 sine squared t cos t dt, like that. And we've showed it. And I'm sure you can guess what the final part's going to be. It's just going to ask us to do the question. So let's do that. I can delete this question now, delete this information. So do that integral. So depending on what exam board you're on, you might do this a couple of different ways. Like for example, the OCR exam board, you've got a formula that you're given in the formula book that will allow you to do that. With Edexcel, unfortunately, you just have to remember that formula. I'll not tell you which one. My preferred method for something like this, when it's giving me a little bit of grief here. 1 second. Right, try again. Let's get rid of that. So I'll not tell you which formula in case it spoils it, but my preferred way of doing this, if we're unsure, is to do it without the formula booklet. So do it so it doesn't seem to be letting me paste it on the screen there. Basically it says just do the integral. So use substitution, use a suitable substitution is my clue if you can't find the relevant formula. Yeah, for some reason it disappears when I click on it. So part D, just do the integral. I think the substitution that will make this easiest would be u equals sine t, if you do it that way. Now it wants to let me. There we go. In a particular form, a plus b root 3. So let u equal sine t. Which means that the integral equals 64 u squared cos t dt du by dt equals cos t, which means that dt equals 1 over cos t du, making the integral equal to the integral of 64 u squared cos t times 1 over cos t du, making it nice, equals the integral of 64 u squared. Now let's sort the limits out. There were t limits and now the u limits. So t equals pi over 2 implies that u equals cos of pi over 2, sorry, sine of pi over 2 rather, equals 1. T is pi over 3 implies the u limit is sine of pi over 3. And I always get these mixed up, so I'm going to use the calculator for that one. Sine of pi over 3 is root 3 over 2. So the lower limit is root 3 over 2. So we've got between 1 and root 3 over 2. Which means that I equals 64u cubed over 3 between 1 and root 3 over 2. Let's just double check that I've got those limits the right way around. Yeah, pi over 3 was the lower limit. Equals 64 thirds of 1 cubed take 64 thirds of root 3 over 2 cubed. I suspect if I put this one in the calculator, it's going to give me a non-exact answer. Let's see. Could be wrong. So it might be that I just have to use algebra. So root 3 over 2 cubed. No. Gave us a third. Brilliant. Okay, so times minus 64 over 3. Is minus 8 root 3. So that's 64 thirds minus 8 root 3. As required, it wanted the answer in that form, a plus b root 3. So that's it. I'm really hoping that you found that useful. Some